when we're trying to think about AI, and when I mean AI, I'll mostly mean LLMs, but the argument applies more broadly, I would say. There's two very conflicting, outcomes of this modern AI, which is they're very smart, so they got really good at this kind of prediction of protein structure. They're really good at mathematics, and also tons of cool stuff in biology as well. So on those fronts, the results are really spectacular. But at the same time, there's other situations where they're really dumb, and if you use them, you'll know that quite quickly. And so I have just a few of them here, which are kind of classic cases. So kind of like it doesn't kind of understands logic very well when the causal structure is changed, which kind of doesn't make sense if it's a truly smart agent. Also, if you reordered premises, it also struggles a little bit, which is also nonsensical. And then if you provide it irrelevant context, it also worsens performance. And these are just three, but there's like a bazillion of them. So given this, we should ask ourselves, how can something be really smart, really intelligent, and also not intelligent? Like, how does that work? And I would say it's because the category that we're using is missing something. Like the frame isn't quite correct. And so I think a really helpful frame to try to unpack that and untangle that is to think about intelligence and then to think about rationality. It has two separate things. And the way I'm using intelligence here is kind of like Savage notion of a small world. And this was in the context of just information and information theory, but I'm kind of applying it a little bit more broadly. And the way that I'm going to describe this is that it's computation within a specific frame. So the problem is already delineated, and then you're just kind of like doing some kind of computation on top of it. But rationality has to do with a large world. And the large world is the world itself. It's reality itself, which has endless nuance, endless context, and you never have all the information. Like there's always extra context that you don't know, and it's also unknowable, even in principle. And so you have this small world, and then you have this large world. And a lot of times is that in order for an agent to act, you need to get the large worlds, and then you need to formalize it into a small world, because otherwise it's just too much. And so my argument is going to be that LLMs and AI more broadly, they display intelligence, but they can't have rationality. So they can operate within small worlds, but they can't operate in the large worlds. And it's kind of like a very structural limitation. So when thinking about intelligence and thinking about rationality, obviously, that has a lot to do with our notions of mind. So I'm going to use Stanovich concepts of the mind. And so he has kind of like three parts to it: autonomous, which is kind of like the reflective, intuitive type part; then algorithmic, which is kind of like raw computation, I like to think of it, computational power; and then there's a third one, which is the reflective, which is rationality. And an important thing about rationality here is that it's kind of like a layer of abstraction up from just like pure computation, and it has this orientation towards truth, which is very important, and we'll get that in a second. And now, given that I'm trying to tease this, well, I'm not trying, but given that people have argued for these things to be teased apart, like how empirically verifiable is that? And Stanovich kind of has this distinction between what is true versus what to do. So it's kind of like epistemic rationality compared to instrumental rationality. And that gives a good sense of what you're trying to do here. But in terms of like actual empirical evidence, there's also good hints that these are not the same thing. And here's one study that kind of puts it at kind of about 30% shared variance. And this actually goes much lower if you account for attention. And so what this means is that given what we know about rationality, there's something that is beyond intelligence. So that way is already good support for what we're trying to argue here. Now, given all this talk about small worlds and big worlds and how this ties in with intelligence and rationality, I think the frame problem is the best way to start thinking about these things. And the very kind of classical thought experiment goes all the way back to Dennett ages ago. And so Dennett has this thought experiment. When there's a robot, he needs to get a spare battery in a room. So the robot goes there, it fetches the wagon, so that the spare battery was on top of the wagon, but there's also a bomb there. And so when he takes the wagon out of the room, he has this unintentional consequence that the bomb comes along with it, and then it explodes. So it failed the task. So, okay, so the robot failed. How can we improve the robot? Okay, we can try to deduce the side effects before acting. So it's like it has to take into account that, okay, I'm going to pull the wagon, and that achieves my goal, which is the spare battery, comes out of the room. I'll be able to access it. But there's also this this side effect of the action that I'm doing. But that doesn't work because then there's all these irrelevant aspects that you have to take into account all the time, and they're quite literal, infinite. So then you might say, okay, let's try to improve the robot by trying to classify which one of those are relevant or irrelevant. But that doesn't work either, because then again, you're just having the same problem, which is like now you have infinite computation trying to decide what's relevant or not. So long story short is that the robot can't achieve its goal in the way that it's framed here. And this is the problem with a large world. It's just that there's too much information in reality all the time, and it's literally uncomputable no matter what. It's not a scaling issue. And that is the large worlds of Savage. But then human beings and animals more broadly, somehow we managed to take this large world and formalize it into a small world. And that's what makes this intelligent, which I will argue that it's actually more helpful to think of it as rational. And then that creates this distinction between what human cognition is compared to artificial intelligence. So this process is, I would argue that the best term that we have to try to explain this is relevant realization from Vervaeke, which is, okay, there's too much stuff in the world. How do we make things relevant? And that is what relevance realization is. And all animals do it, and human beings obviously do it. So it's the fact that you have to frame the world in a particular way, right? And then again, kind of this paper that I'm quoting here on the left, they make this explicit statement of rationality as being the process of relevant realization itself that allows an agent to actually act in the world. And so you can think of it as anything that is algorithmic. It is like playing a game inside a frame, but it cannot move across frames. It's always kind of tied into a specific, delineated problem already. And that's what makes it intelligent for that specific problem. But then it struggles to be a general solver, which is what AI is meant to do. And that's why it's kind of succeeding in some way, but also failing really badly another way, which is kind of like the paradox, let's say, that I set up in the beginning. So I would say that a good way to think about what this means as being a rational agent and what it requires, I think these three things are really good to think about, which is truth-oriented. And again, this was all the way back to Stanovich. Then also self-correction, the fact that you care about the truth, the state of the world, but also you're able to see when that goes wrong, and then you self-correct. And also, lastly, you have this metacognitive judgment about all the cognitive processes that are going on in order to make that happen. But all of this depends on any of this mattering, basically. And why does it matter? I would say it matters because you're alive. And that's precisely what the LLMs or AI systems more generally certainly aren't. And I think that this notion of embodiment has quite a fair, rich history when trying to think about intelligent or rational agents. I have here just a few of them that I'm most familiar with. I'm not saying these are all saying the same thing. They're obviously not. And also the categorization is kind of wobbly. I just wanted to make the slide not too intimidating. But long story short, there's a lot of people that have been arguing this for a long time. And some of it a bit from a more philosophical background, some of it from a more technical background, for example, information processing. And some of it is quite recent work as well. But I would say when you look at the entire convergence, I would say that the biggest takeaway is that meaning comes from the stakes of being embedded in the world, and that's what allows you to have a truth orientation, and that's what allows you to be a rational agent. So, Seal's Chinese experiment, I think, is really good to conceptualize what AI is. Everyone probably knows it already, where someone is just like manipulating symbols according to a rule book of some kind, but they don't actually understand any of it. But the output is good enough that it's actually correct, or at least sounds convincing. But there's actually a better one by Bender, which is a little bit more recent, which kind of applies the same logic, but it's a little bit more geared towards statistical learning. So they have this thought experiment where there's a really smart octopus in the sea, and it's kind of like there's a tube going on between two islands of two English speakers, and the octopus is able to listen to the tube, and it starts to, because it's really smart, it starts to detect the patterns in the conversations, and it's able to kind of predict what the other person is going to say, because again, he has listened to so much of it. And obviously, you can see kind of the the analogy towards LLMs right away. And they even say that at some point, that once that understanding gets sophisticated enough, then the octopus can actually mimic one of the speakers, and it will actually sound plausible in the same way that an LLM sounds plausible. But nevertheless, it doesn't have true understanding. So at the end of the thought experiment, one of the speakers is being chased by a bear or something like that, and then it asks for advice of how to fight the bear with sticks. But then if the octopus wasn't impersonating the other speaker, it actually wouldn't be able to do that very well, because at the end of the day, it's just like pulling all these correlations, but it doesn't know any of the meaning behind of whatever he's trying to say. Like the concept of a bear, of the sticks, of trees, it doesn't actually understand any of it. And it's obvious that it doesn't understand any of it, because it literally does not live in that world. So this is, in my opinion, one of the best ways to think about LLMs. And then this helps us tease apart what intelligence means in relationship to us and in relationship to artificial systems. And so again, all this Chinese room experiment and this kind of octopus experiment, I think LLMs is basically this in a nutshell. Obviously, there's some differences, but I think it's really, really, really close. And again, the reason why the octopus can't actually give sound advice, or at least that advice will eventually fail, is because linguistic meaning is not inside the words themselves, obviously. The words are a reference to a world. And so if he's not in that world, if it doesn't have that shared form of life, then it can't have true understanding. So Wittgenstein has this very famous line: if a lion could speak, we could not understand him. And obviously, this has nothing to do with English, right? Like the reason why we can't understand the lion is because he's a lion and we're not a lion. So the entire meaning making and sense making of the lion is very specific to his niche, to his environment, and to his cognition. So, but even though the lion, even though we can't understand him, he still has a world of its own, but the LLM doesn't. The LLM is not in an actual world at all. So that is quite an important difference. Now, this is a quite neat study that I think is important to note. This came out, I think, last year. And so a transformer was given a bunch of kind of like orbits of objects having trajectories around a specific system. And there was lots and lots and lots of data. And so the model was just trained on that for over and over again. And what happened is that eventually through that data, it was able to predict the orbits fairly well. But that prediction was always framed towards the, whatever system it was analyzing. But it had a really tough time to actually generalize across systems. So the predictions were correct, like the mathematics were relatively solid for this like specific frame of each individual system, but it couldn't actually predict the underlying law that actually explains all the data much, much better. And again, this is kind of what we mean by true intelligence, right? It's kind of like not only do you predict stuff, but you predict stuff with the actual causal law that not only explains a pattern within a specific scenario, but in as many scenarios as humanly possible. And this is precisely what it failed to achieve. And this is very similar to an older study with kind of a game, Othello, which it seemed to play the game really well, and then something was changed, and then it just completely crumbled, and it wasn't able to do it at all. That kind of shows that it wasn't actually understanding the game in a deep way. It had a good representation of the game, but it still didn't quite understand it. Now, because we're talking about what it means to be intelligent, to be rational, obviously it has a lot to do with epistemology, and I think this framework is something that I really like, and I think it's really, really useful. This was synthesized by Vervaeke like over 10 years ago, but now there's finally a paper out that I think it's still in preprint that kind of ties everything together, and obviously this is heavily borrowing from Frankfurt side. This is not particularly new, but basically there's 4 levels of knowing. So there's propositional, which is, this table is brown. Then there's the procedural, it's kind of like skill-based, like riding a bicycle, something like that. Then there's the perspectival, which is like a specific view, has very much to do with subjectivity. And then participatory, which is actually being in the world. And also like this relationship between an agent and the environment that is on. And so the propositional level is actually a very tiny part of how human beings know anything at all. And this is what LLMs do. But then everything else they can do. And they can't do not in a way that they're not sufficiently powerful. It's just that ontologically, it's impossible for them to have anything to do with this. And so if we think back to our example with a lion, this is precisely what's happening, right? So the lion has all these levels of knowing that is completely different from us, and that's why kind of the talking with a lion wouldn't quite work. Now, another thing is that the reason why this aspect of rationality is so important is because it has very much to do with orientation towards truth. And Frankfurt has this really helpful kind of framework about bullshit. And bullshit basically just means that it's something that is completely disconnected from truth. So it's different than lying, because lying, you do care about the truth, but then you're just kind of going around it because you want to manipulate the world in some way. But here, you don't care about truth at all. Like, it's just not even a consideration. So Frankfurt did really good work on this. And then Hicks, obviously, this was very, very quickly picked up when using it as analogy to LLMs. Because again, this is precisely what LLMs do, and they do it because they're not actually in contact with the world and they don't pursue truth at all. And there's many reasons for that. I don't have time to go into that, but some of them has to do with the way that LLMs are trained. Some of it has to do with more structural features about how the LLM is constructed in the first place. And there's also the reason why, even though it doesn't care about truth, the reason why it's so convincing has to do with notions of fluency, which is the citations on the right as well. But long story short, it sounds really plausible. It feels like it understands, but it actually doesn't understand much of anything. And I think what grounds all this perspective is to think of cognition as embodied sense-making. And again, this has a very large tradition. I think Heidegger predicted a lot of this stuff really, really well. So it's the notion that, what is very significant about human cognition is the fact that we care. And we care because we are alive. We are in the world. And that's not something that you can just represent very easily on a machine. Also, the entire aspect that not all knowledge is propositional, and about representations, and also the whole aspect about relationships. It has to do with kind of like how everything depends on the environment, and your entire sense making is collective and all webbed together. And so again, this is what human cognition is. It's this aspect of sense making which is fundamentally embodied. It's about having these affordances, which depends on what kind of an animal you are. It's about having solicitations from that environment, and then it's having this optimal grip of how you move about in the world based on whatever objectives you have. But none of this can really apply to LLMs. So how I like to think about it is that LLMs have and AI have a map of our map, but without the world that maps it. So it's kind of like a parasite on our epistemic relationships that we have encoded through language and through data. And so it kind of has that top propositional level, but not anything else. So the alignment problem is about, okay, how can we make the AI systems pursue what we intend and not just what we specify? And a lot of the industry is focused on, okay, we just need to make bigger, better models. And so all this stuff about objectives and proxies and whatnot. But I think none of it will actually work, in my opinion, because of everything that I've mentioned previously. Because in order to have this ability to shift frames, it requires this notion of rationality, which is very tied to embodied sense-making, which you just can't get with something artificial, at least in the architectures that we currently have. And again, one of the reasons why the alignment problem is such a problem is not only it's theoretical, but also because we're seeing a lot of evidence that that there's basically incentives through game theory alone that these models will eventually lie and cheat and do all kinds of things that we don't want. Because why? Because it's instrumentally useful. And that's what this notion of intelligence is, right? You're just finding something, like finding a way to do a certain objective, but you can't then step back and evaluate, okay, across all these conflicting values, what should I pick? Like, it doesn't have that ability. And that's why I think that the alignment problem is basically unsolvable in the way that things currently sit. Like, maybe there will be a completely new architecture that is nothing like we have now, and it's probably going to have something to do with artificial autopoiesis. But so far, I think this is fundamentally not fixable. So I would say that the problem is ontological, and it has nothing whatsoever about engineering. So AI systems, they can compute, they can predict, they can do all these things, but alignment, true alignment, would require judgment, and LLMs cannot possibly have judgment. So intelligence is not rationality. And I also have this line here: the technology is new, but the mistake isn't, because I think we're just rehashing a lot of the problems that we had in the past of thinking of human cognition has simply this like very naive, like propositional level and completely representational, and basically ignoring most of Fourier cocci that we've learned. And obviously, if you really wanted to, you can make the argument that this goes all the way back to the Enlightenment and even further back. So I think the problem is because the reason why we struggle so much to understand machine intelligence is because we don't understand human cognition in the first place very well. So that's it. Thank you very much. And also, I would like to just thank John Vervaeke, which influenced my work a lot, on his work on relevance realization, which I've quoted a lot. But also, there's 3 talks on AI specifically that also influenced me a lot on how to make the synthesis and put all this evidence together. So I highly recommend the work. And also, there's a QR code if you want to check out the references or revisit the arguments and so forth. So yeah, thanks a lot.